In this lecture, we are going to see some of the terminologies and we are going to understand some concept which will help you in your Node.js journey. If you remember, in our file system module, we have seen UTF-8, and for reading the file as well as for writing the file, we have passed this encoding. To understand completely about this, first we will understand what is binary data, what is character set, what is character encoding, and then finally we will understand this UTF-8. Okay, first let us start with binary data. And as we all know, our computers can only understand zeros and ones. Our computers represent and store all the data in binary, that is zeros and ones. And this zeros and one, you can also call it as binary digits or bits. And this bit is nothing but it is a single unit of data that can either have one of the two values. It can either have 0 or it can have 1. Apart from this, this bit is not going to contain any value. It can either have 0 or it can either have 1. And these bits are used to represent and store all type of digital information. Doesn't matter if you're having number, if you're having text, if you're having images, if you're having audio, if you're having video, all this form of data will be stored inside the computer in the form of bits by encoding them into binary form. If I take an example of numbers, numbers will be converted to binary using this base to numeric system. So here I am having 0 to 10 decimal number, and for each number, this is the binary number represented using base to numeric system. For 0, we have 0. For 1, we have 1. For 2, you can see we have 1 0. Whatever binary representation we have, in that we will only have zeros and ones. So this is how our decimal numbers will be converted to binary number. Similarly, doesn't matter what digital information we are having, each and every data will be converted to binary number, and only then that number will be stored inside the computer. So always remember, directly whatever data you are entering, that will not be stored as it is. So whatever data you are working, our computer will be converting that data into its binary representation, and that binary representation will be stored inside the computer. Now, for 5, binary representation will be 101. For 6, it will be 110, and it keeps on going. But now, the question is, how does the computer know how to perform that conversion? Because we are having different digital information like text, characters, images, videos, audio, and lot of things. So, how does our computer know how to perform this type of conversion? Well, as I mentioned, by using this base to numeric system, here you can see I am having 2 power 0, 2 power 1, 2 power 2, and corresponding to that, all the values are displayed. Now, I just want binary representation of 5. So here I can just add the numbers. 4 plus 1, I will get 5. So whichever numbers I am adding, there we are going to add 1, and in between we will be adding 0. So this will be binary representation of 5. If you want to find for 6, 4 plus 2 it is 6. So here and here 1, and here I will be having 0. So this will be binary representation of 6. Similarly, whatever numbers you want to add, accordingly you will be calculating the numbers and then you will be adding these bits. Okay, this is fine. Whatever we have seen, it is only for numbers. So again, you might have questions. How are characters represented? For normal numbers, actually they are number. So accordingly, we will calculate and we are going to have the result. But how characters will be represented and how they are converted into binary representation. So here, for characters, what happens? Our system or our computer, for each and every character, first they will be converting to number, and whatever number we are having, that number will be converted to binary representation using this base to numeric system. For example, for character K, we are having this number 107, and these numbers are already predefined. Now this character will be given this number. Now we are having this 107, and for this number, entire thing will be converted into its binary representation, and this will be the final binary representation of K, which will be stored in my computer. So this is how characters will be converted. For numbers, whatever number we are having, directly it will be converted to binary representation. But for characters, first it will be converted to number, and then that number will be converted to binary representation. Now again, definitely you should be having this question: how can our computer know difference between the character K and the number 107? Because I mentioned character K will be converted to number, and then that number will be converted to binary representation. So same binary representation will also be given to 107 number. Then how our computer understand what is the difference between character K, for which we have number 107, and normal number 107? So to answer this, consider programming languages like C++ or C. Inside this, let it be any number of character, or even for a one character, data will be stored in the data type like char or string. But in high level languages like Python, JavaScript, computers will understand when I refer to K, I am referring to the character K, because that character K will be stored inside the variable. That indicates it is a character and it is not a number. So in languages like C and C++, we will tell this is the character or string. But in higher level languages like Java or Python, our computer will understand, because whatever data we are storing, string data, that we are going to assign to the variable. So easily it will understand we are referring to the character K. Now let me show you how to find number of character K, that is nothing but character code for letter K. I have opened browser console. Inside this, I will be writing character K. Okay, it is string, so I will be writing in single quotes. You can also use double quotes. Dot. On this string, we are having this method char code at. Call this. As soon as I hit enter, you can see for letter K, we are having this number 107. Okay, these are already predefined, so you don't have to by heart, or as well as we cannot change these numbers. Now for capital K, I will be writing char code at. Hit enter. Now you can see for lower case as well as for capital case, we are having different numbers. So this character code is different for each and every character, different for each and every symbol. Here I will write at. Then for this, I will be writing this character code. Hit enter. Again for this, I will be having different number. And whatever number we are having, then this number will be converted to binary representation, and that number will be stored inside our computer. So now I mentioned you whatever numbers we are having for characters, those are predefined. So how our computer will know what number will represent each character? In our case, we have considered K. So how our computer will understand K should be represented as 107. So to understand this, let us move to the second topic, that is character set. And this character set, you can imagine like a dictionary where it will be mapping each character to unique numeric codes like how we are having in dictionary. So for each and every character, we are already having the numeric codes. Let me just open this link. Now here you can see this is the ASCII table. For character A, we are having 65. For lowercase k, we are having 107. For capital K, we are having 75. And for at, we are having 64. So for each and every symbol, you can see for space, for exclamatory, for double quotes, for hash, for each and everything, numbers are already mapped. And whatever numbers are mapped, that numbers will be converted to binary representation and that will be stored inside our computer. You can see for delete, for parenthesis, for question mark, for equal to, for each and every character, numbers are already predefined. Basically, these numbers are already mapped to the characters. It is not the end. Let us see different types of character sets. First, we are having ASCII. I believe you have already heard about this. It stands for American Standard Code for Information Interchange. And second is Unicode. And in browser, what example we saw using char code at, that was the Unicode example. Now one by one, let us understand this ASCII. It will be having oldest character set and it will only support 128 characters and it will be including English letters, numbers and basic symbols. For example, for capital A, it will be mapped 65. For lowercase a, it will be mapped 97. But here we are having limitations. It is only going to support English language, so it is very limited. But in world, if you consider, we are having multiple languages. So in that case, if you choose this ASCII character set, then you will be having lot of limitation and each and every character will not have the numeric data. So this ASCII is very limited. Instead, you can go with Unicode and it will be supporting modern and comprehensive character set and it will be supporting characters from all the languages. Let it be Chinese, let it be any language. Using this Unicode, it is going to support for all the languages and it can represent over 1 million characters. Okay, this is huge. And for example, using this Unicode, for every alphabet, we will have the number. For every emoji, for mathematical symbols, for Asian scripts like old scripts, for each and everything, we will be having the number. So this is very huge and also we are not having limitation like how we had in ASCII. I hope till now you have understanding what is binary data, how the numbers will be converted to binary representation, how characters will be represented into binary representation, what is character set and different types of character set. Now you might think we are having characters which are mapped to numbers and then that numbers will be converted into binary representation. This is all we have seen. But the topic doesn't end here. Whatever we have seen for characters, it is partially true. So to understand complete detail, let us move to our third topic, that is character encoding. So to understand complete thing, let us move to the third topic, that is character encoding. And just think of character encoding as translation rules. So basically, using this character encoding, it will tell how to convert those numbers to a computer friendly format. Like for each and every character, we are having the numbers. So using this character encoding, we will know how to convert those numbers. So character encoding determines how a character's number is converted into binary data so it can be stored in a computer. And here we are having two types of encoding. We have ASCII encoding and we have UTF, and this is most popular and this is what we have seen in our FS module system. So one by one, let us understand. Using this ASCII encoding, it will be using 7 bits per character. Bit is nothing but it can either have 0 or 1. Using this ASCII encoding, we can only use 7 bits per character, which means in a row we can only have 7 zeros and ones which will be representing that character. And it is very limited and it will only work for English characters. But now let us see UTF-8 most common and most popular, and it is like universal translator that will be working everywhere. So here we are going to have variable length encoding, and it will be using 1 to 4 bytes per character. I will tell you what is byte, and also it is very flexible and efficient, and it has backward compatible with ASCII. So it has no limitation. Easily you can use this encoding type, that is UTF-8. So now the question is, so whatever numbers are mapped to the characters, how we are going to convert those code into a format that our computers understand. And this UTF-8 is a smart and flexible encoding system that is going to translate character numbers into binary format. By itself, it is going to decide how many bits or bytes are needed for each and every character. Now let us see some of the key points of UTF-8. First, bytes and bits. So bit is nothing but it can either be 0 or 1. Apart from this, it will not be containing any number. And byte is nothing but if we are having 8 bits, this is called as 1 byte. Okay, complete group of 8 bit is called as 1 byte. I hope you understood what is bit and what is byte. Second key point, binary representation in UTF format. For 4, we are going to have 100 binary representation, but using this UTF-8, what it will do, this complete 4, it will be making as 1 byte. So here we are having 3 digits. Now to make this complete 1 byte, we need 5 more bits. So before this one, it will simply going to add 5 more zeros, and after that we will have this 100. This is how numbers will be represented. So it is just going to make one complete byte, and this is how binary representation will be looking for number 4. Then we are having character representation. For character K, we are having the assigned number as 107. And then using this UTF-8, this will be represented with this number. And here also if you see, we are having 8 bits which is as equal to 1 byte. Then fourth point, efficiency of UTF-8. So UTF-8 adjusts the number of bytes depending on the complexity of the character. Okay, always it is not going to be 1 byte. It is just going to adjust based on the complexity of the character. For example, for letters, it will be giving 1 byte. For emojis or for Chinese characters, it will be up to 4 bytes. So just imagine 4 bytes, which means 8 into 4, we will be having 32 bits. Up to 4 bytes. It is not exactly 4 bytes. Up to 4 bytes. Accordingly, it will adjust. For example, for characters, 1 byte. For emojis, it can take 4 bytes. For this Chinese characters, it can take up to 3 bytes. Now, let us see why this UTF-8 is important. We have seen almost all the advantages. Let us see some of the points here. It efficiently stores data while being flexible enough to handle different characters. As I mentioned, it will handle emojis, it will handle Chinese characters, it will handle Asian scripts. So each and everything it is going to handle, and it will be working across different platforms. And also it is standard for web and most modern systems. Similar encoding rules apply to other types of data like images, videos, ensuring compatibility across devices and platforms. Okay, we have seen only about characters and numbers. But same rules will be applied for images, videos, audios, or any kind of digital information. Now from this lecture, you might have this interview questions. Why do we need different character set? Now you are having the answer. And is UTF perfect? You can also tell this answer, and accordingly, whatever you understood from this lecture, you can easily explain in your interviews. So to summarize, computers don't understand characters directly. They convert characters to numbers, and then that numbers will be converted to binary. Unicode is nothing but universal character mapping. UTF-8, a flexible encoding method widely used across all the platforms. So always the best practice whenever you are working with character data, always prefer UTF-8, which will have maximum compatibility and efficiency. Do not select ASCII, always go with UTF-8.